All right, well, welcome back. So what I want to do right now is go over briefly with you lesson 5.4, which is making predictions with experimental probability. So in this case, we've done a little bit of it where we can take what has already been done, we can use that information, and we can predict what we think is going to happen in the future. Okay, so we've already done a little bit of that, so we're going to do a little bit more right here in this particular lesson. So just follow along with me. Please take notes if you would, and if you need to go back and rewatch the video, then you can do that. So let's go ahead and get started. If you would, please turn to lesson 5.4, which is making predictions with experimental probability. So there's a couple of different models or examples I want to go over this with you. So let's just go ahead and talk about example 1. It says Danae found that the experimental probability of her making a bullseye when throwing darts is 0.2 or 20%. So out of 75 throws, about how many bullseyes could she predict that she would make? So what we look here is she's saying that she's going to make a bullseye 0.2 or 20% of the time is approximately what she says. How well she does that. Let me move that back a little. So out of 75 throws, about how many bullseyes could we predict? Well, we know that she thinks that out of 75, 20% of 75 is what she's going to do. Every time she throws the dart, 20% of the time she's going to get a bullseye. That's what she has done in the past. That's her experimental probability. So we can do it with the proportion, or we can do it with an equation. I want to just go ahead and continue to focus on the proportions. All right. So what it has here is we put what we know on the left-hand side, and what we know is we know that 2 out of 10 times she gets a bullseye. Okay, so that's 2 out of 10. That's what we know. On the right side, we put what we're trying to find out. So what we're trying to find out is, well, out of 75 times, how many times is she going to get a bullseye? So we set it up. You can cross multiply and divide. So that's going to be x. Cross multiply. We get 10x is equal to 150. We divide both sides by 10. And we get that x is equal to 15 bullseyes. Yeah, 15 bullseyes. So there we are. All right. We can do this. We can use what's happened in the past to help us predict what's going to happen in the future. 20% of the time feels that she's going to make a bullseye. So we do 20% of 75. What you know on the left, what you're trying to find out on the right. So here's an example right here under the your turn. So I want you to work on that. It says a car rental company sells accident insurance to 24% of its customers. So accident insurance to 24% of its customers. Out of 550 customers, about how many customers are predicted to purchase insurance? You've done this before. You've set these up. It's nothing new. So we're going to set up a proportion. We know that 24 out of 100 do get it. So if you want, you can put that on the right. We typically put the percents on the right, so that's fine if you want to do that this time. That's 24 out of 100. So I want to know how many out of 550 is what I want to do. So I can cross multiply and divide by 100 right here. So I need to do 550 times 24. So we're going to work that out right underneath here. We'll do 550 times 24. And I get 13,200. So that is 100x equals 13,200. You know we divide now by the number in front of the variable. So we get x is equal to 132. So how many customers are predicted to purchase insurance? That would be 132 customers. There we are, 132. All right, now let's use experimental probability for a different way. So go ahead and turn to the next page. Look at example 2. We're going to try to predict something that happens in the future. So read this if you would. It says a doctor's office records data and concludes that on average 11% of patients call to reschedule their appointments per week. So 11% reschedule appointments. The office manager predicts that 23 appointments will be rescheduled out of the 240 appointments during the week. Explain whether the prediction is reasonable. So we need to find out, is 23%, or I'm sorry, are 23 appointments out of 240 total ones, is that close to 11%? We have to prove that. And if it's close to 11%, then we know it's reasonable. So we have to see if this here, if those are 11%. So you could do it one way where you could just get 11% of this number and see if that is around 23 appointments, if you wanted to. So let's approach it that way. And that's what's been done right here. So we know we have 11% over 100. In this case, they wrote it on the left-hand side, and that's fine if that's what you choose to do. And we want to know how many out of 240 is that. So we can, in this case, they multiplied across. They did this times 2.4. You can cross multiply if you want. Okay, we have always cross multiplied, so if that's what you choose to do, that's fine. Let's go ahead and just show that over here, the way that we have always done it. So we're going to cross multiply 240 times 11. So right here I'm going to do 240 times 11. That's 042. 042. That's 2640. So that is now 100x is equal to 2,640. We divide both sides by 100. So move the decimal 2 places to the left, and you get 26.4%. Yeah, so that's 26, I'm sorry, not 26.4%. That's 26.4 customers that are going to reschedule their appointments. Now, they said that they think it's going to be approximately 23 appointments out of the 240. So we need to find out, is this close to what they predicted, which was 23 customers? And 26 is pretty close to 23. So in that case, explain whether the prediction is reasonable. Yeah, it's pretty reasonable. They're very close. They're only approximately 3 customers off. So not too bad on that case. Okay. Let's go ahead and do a your turn right now. So number 3 on this same page, 176, it says, in emails to monthly readers of a newsletter, 3% of the emails come back undelivered. So 3% emails undelivered. The editor predicts that if he sends out 12,372 emails, he's going to receive 437 that were undelivered. So we need to figure out, is 437 out of this number, 12,372, is it 3%? Okay? So let's go ahead and figure that out. Let's get 3% of this and see if this is going to be close to it. So we're going to go ahead and write 3 over 100. And this right here is 12,372. We're going to put X on top. And we want this number here to be close to 437, if it's going to actually be reasonable or not. So we cross multiply here. So I'm going to do 12,372 times 3. We get 6. Let's see. 1, 2, 3 times 3 is 9, plus 2 is 11. 3 times 2 is 6. That's coming in clear. Plus 1 is 7, and we have 3. So we have 37,116. I'm going to move. Oops. There we are. We move that over there. So we're going to do now 100x is equal to 37,116. Divide both sides by 100. And you get x is equal to 371.16 undeliverable emails. Okay? Now if I've done my math right, you want to double check me on this. So this times that is around 36. So yeah, I think so. So is this close to 3%? Okay? I'm sorry, this is 3%. They feel that this number is 3%. So, do you agree with this prediction? I would say no, I don't. Because he's over his prediction by approximately about 60 to 70 emails. So I would say it's not very close. Okay? Let's go ahead and go to the next one. So, let's see, is there anything I want to do on this one? No, not really. How about this one? On average, 24% of customers who buy shoes in a particular store buy 2 or more pairs. So, 24% of customers buy 2 or more pairs of shoes. One weekend, 350 customers purchase shoes. How many can be predicted to buy 2 or more pairs? If 107 customers buy more than 2 pairs, did more customers than normal buy 2 or more pairs? So let's find out what's normal, okay? We know that 24% of customers usually buy 2 or more pair. So let's get 24% of this number here. So we want to have x over 350 is 24 over 100. So we're going to cross multiply. And we're going to do 350 times 24. Oops, sorry about that. That would be 0, 0. We got 4, 8. So we have 8,400. Yeah, okay. So we have 100x is equal to 8,400. We divide both sides by 100. Okay, and so x is equal to 84 customers that buy double shoes. So if 107 customers buy more than 2 pairs of shoes, did more customers than normal buy 2 or more pairs? This here is normal. That's normal right there. This right here is not normal. So did they buy more than 2 pair of shoes? And they did. Shoes. Did they did more customers than normal? Yeah, more customers than normal. This is how many customers did. This is what the normal is. Okay. So once again, you've done things like this before. Okay. We haven't necessarily called it experimental probability, but we saw proportions. So we're going to use the same information dealing with proportions, and we're just going to apply it to experimental probability. So if you would right now, you can work on the guided practice, or you could get started on the homework that's due Monday. The homework that is due Monday is going to be 5.4 independent practice, numbers 8 through 11. Okay, I believe it's just 8 through 11. Let's see. Actually, it's 8 through 13. 8 through 13. That's what I want you working on. So, all right. If you got any questions, you can ask a neighbor if you need to, or if over the weekend you need anything, you can always post questions to each other on Edmodo. All right. Thanks for watching.